Hi, in this video we will see about one of the interesting problem based on bit manipulation, and we will try to solve this problem using dynamic programming memorization. The problem statement is given a non-negative integer number and we need to find the number of ones present in the binary representation and we need to return them as array. For example, if we are given with the number 6, we need to find the number of ones present in 0, 1, 2, 3, 4, 5 and 6. So here for 0 we have 0, and for 1 we have 1, and for 2 we have 1, and for 3 we have 2, and for 4 we have 1, and for 5 we have 2, and for 6 we have 2. Now we need to return array 0, 1, 1, 2, 1, 2, 1. We need to convert the given number to binary form and we need to find the number of ones present here. This can be easily solved with the time complexity n into the number of bits present in their binary form. But we are specifically asked to solve this in order of n time complexity and order of n space complexity. And if you can able to solve this in one pass, that will be really good. We will try to find the intuition how to solve this problem and we will try to find our logic from there. So here, one thing to notice in a binary representation, each and every bit, if you try to notice their corresponding values, only the 0th bit will be 1. All other bit will be even. So it will be starting like 1, 2, 4, 8, 16, 32, 64, 128 and so on. Here we know when you try to add even with even, it will be always even. And if you need to get odd, we need to have one of the operand as odd. For odd number, the last bit will always have 1, and for even, we will always have the last bit is 0. This is a basic understanding we need to have to solve this problem, with which we will try to find how many number of ones present number 19. So we know for 19, it will have 1 in the last bit. And if you have 1 in the last bit, it will increment the value by 1. So if it increments the value by 1, if you know the number of ones present in the previous value, which is 18, we can increment the value by 1, the number of ones present in 18 plus 1. In 18, we have 2 ones and we know 18 is an even number and so the 0th bit is 0. Here, to find the number of ones present in 19, we just need to add 1 to it, and if you add 1 to it, it will be like 3. So the number of ones present in 19 is 3. And for even, we know the last bit will be always 0. So we are not worried about 0, we are just worried only about the number of ones present in the given numbers binary representation. So we can simply ignore the last bit. If we simply ignore the last bit, we can do right shift. If we do right shift, we will get a smaller number which we might have already found. In this case, the binary representation of 20 is 10100. Here, we are not worried about the last bit, so I am doing right shift by 1. So if I do right shift by 1, I will get 1010, which is 10, which we have already found there is 2 ones present in the 10. So for 20, we will have 2 ones. So the logic is for our number, you need to find the previous number of ones and increment it by 1. And for even number, you need to do right shift by 1 and you need to copy that exact value, the number of ones present in that number, to this number. This I am trying to solve in Java. You can use any programming language as you wish. The core logic remains the same. Here I am just declaring the result array as size num plus 1 because we need to even find the value of 0. So for number 6 we need to find 7 values, so I am having number plus 1. And I am initializing the result 0 with 0 and result 1 with 1 because we know for number 0 there will be no ones present, and for number 1 we will have only 1 present in that binary representation. Now I am doing a for loop. I am starting from the value 2 and to the number. Here if it is even number, right shift, and I am assigning the same number of ones present in the right shifted value to this number, and if it's an odd number, I am just getting the number of ones present in the previous value and adding 1 to it and assigning it to this number, and I am returning the result. Thanks for watching this video. For more videos on bit manipulation, check my video description. If you want to learn more about algorithms or any computer science topic, subscribe to this channel. Thanks for watching and thanks for subscribing. See you in my next video.